All right, so section 3.3 is talking about dividing polynomials. Recall that long division, first recall what long division is. Let's just take 5,231 divided by 7. So this is just a reminder of how to do long division. 7 goes into 5 0 times, so we kind of skip that one if we want to. 7 goes into 52. That'd be 6 times, 7 times. So we take 7 times 7, we get 49. So, just be very conscious of what we're doing here. We're taking 7 times 7 to get 49. Then I'm changing the sign on that 49 and I'm adding. Then I bring down the next number and see how many times 7 goes into 33. 7 goes into 33, I believe, 4 times. 7 times 4 is 28. I'm going to change the sign on that and add. I get 51. 7 times again, 49. Change the sign, add, and I have remainder 2. And then I can write this as 5,231 divided by 7 is equal to my quotient plus my remainder over my divisor. Normally we don't put the little plus here, but there is a plus when we write mixed numbers, so I'm putting a plus because that's how we're going to do it when we do polynomials. You can also write this as a product. You could say 5,231 is equal to 747 times 7 plus 2. Let me just refresh your memory what we did here. If I take this times this, that should give me just 2 short of this number here. That's why that remainder was 2. Another way to look at this is just to say if I just multiply this equation by 7 on both sides, these 7s cancel, so I get my dividend. This is called the dividend. 7 times this, that's my quotient times my divisor plus my remainder. So these are kind of the 2 ways to write a division problem, a multiplication way and a division way. I call this the division algorithm. So that's kind of what I'm talking about up here. So your dividend is equal to your divisor times your quotient plus your remainder. Or you can write it the traditional way and write it as a division problem, and you just get your quotient plus your remainder over your divisor. So when I say division algorithm, I'm talking about this guy here. Use it. So polynomial long division is exactly the same thing. I'm going to take 3x to the 4th minus 5x to the 3rd. Now there is no x squared term in here, so I'm going to put a space holder for my x squared term, so my columns line up. That's not a problem we have when we're doing these numbers because there's always going to be placeholders, but here we can lose it. We may lose our placeholders if there's no term there. Then this is x squared plus 0x plus 1. Okay, so I'm going to see how many times 7 goes into 5. How many times does x squared go into 3x to the 4th? Well, 3x squared times. I put the number here, so when I multiply these two things, I get 3x to the 4th. Or you take 52 divided by 7 to get, to get that 7. Well, here you could take the 3x to the 4th divided by x squared, and it gives you 3x squared. So what you're really doing is you're dividing these to get this, but however you want to look at it, it's the same thing. So now I take my 7 times my 7 to get the 49. Here, I take this times this. To do that, you take this times the first one, 3x to the 4th, this times 0 plus 0, this times positive 1. So what you're really doing here is you're using the distributive property. Then I need to subtract. I change the sign on the 49 and I add them. I need to subtract this. So I'm going to change all the signs and I'm going to add them. 0, negative 5x to the 3rd, negative 3x squared, bring down the next number, bring down the 3, bring down the next term, and then we repeat that process again. X squared goes into negative 5x cubed, negative 5x times, because when I take this times this, I get negative 5x cubed. This times 0, 0. This times 1, negative 5x. Change the signs, plus, minus, plus, and add. 0, negative 3x squared, positive 7x minus 4. Do it again. Minus 3, negative 3x squared plus 0 minus 3. Change the signs. Add 0, 7x minus 1. All right, how many times does x squared go into 7x? Doesn't go in at all. So this is my remainder. This is my quotient. This is my remainder. This is my divisor. This is my dividend. So I could write this as, this is equal to, I would write my quotient, 3x squared minus 5x minus 3, plus, I'm sorry, I'm running out of space here, guys. Delete some of that stuff. My x minus 3 plus my remainder over my divisor. So this is how we would write it as a division problem. Okay? So I'm done. That's polynomial division. It's the same as long division. Express the above using the division algorithm. So that is taking the dividend that's equal to our divisor times our quotient plus our remainder. Our divisor times our quotient plus the remainder. And if we had more time or more motivation, I guess, we could actually distribute this out, expand it, add like terms, add a 7x, subtract a 1, and of course you're going to get this dividend right here. I'd leave that as an exercise to you if you want to see it. Okay? All right, so another example. Let's do this division. 2x to the third. Now I don't have an x squared term, so I like putting in a placeholder there. You have to put a placeholder? Well, try it without. If you line things up properly, you can maybe figure it out, but I find the kids sometimes screw it up. So I don't do that. So x goes into there, 2x squared times this is 2x to the third minus 8x to the second. Change the signs, minus, plus, add, 0, 8x squared, bring down the next term. X goes into that, positive 8x times, because 8x times x is 8x squared, that's what I want. 8x times this is negative 32x. Change the signs and add 0, 2x, bring down the next term. X goes into 2x 2 times. X times 2 is 2x minus 8. Change the signs and add. So I get a remainder of 0. Wow. Recall that if you take 10 and you divide by 5, your remainder is 0. That means that 5 is a factor of 10, and that 5 divides 10 evenly. So what this means is that this x minus 4 is a factor of this polynomial. It divides it evenly. There's no remainder. So this asks for a division, so let's just do the division. I'm going to take this division problem, and I'm going to write it as 2x squared plus 8x plus 2 plus no remainder over the divisor, so I don't even have to write that, right? Basically, this x minus 4 divides this evenly. Express the above problem using the division algorithm. That is the divisor. I'm sorry, the dividend equals the divisor times the quotient plus the remainder. No remainder. So this is kind of why we think I think the division algorithm is kind of important. We basically just factored this cubic polynomial. We've never done that before. We've never really been able to factor something like this before. We kind of just did it. Of course, I had to tell you what the factor was, but later on we'll figure out how to do that. All right, continue in the next video.